Hello? Hello everyone. Today we will continue to look at the content of HCI-Storage. Today we will mainly look at the application of solid-state drives in storage. First of all, we have already introduced the performance advantages, right? In different types of storage systems, they hold a very important position. As for the current solid-state drives, here we can first take a look at this in the picture. The application of ABC3 level, we haven't mentioned this type of application before. So, what does this application mean? First, let's talk about it briefly. An official description would be that A-level applications, like our database applications, primarily focused on high concurrency random read and write operations. B-level applications, on the other hand, involve sequential read and write operations for large capacity files, images, and streaming media. C-level applications are primarily for backup, which is cold data. This is the cold data we mentioned earlier. Now, let's first take a look at A-level applications, which are primarily focused on high concurrency random read and write operations. As for databases, why are they considered A-level applications? It's because in database systems, we often need to handle a large number of concurrent requests simultaneously, and many of these concurrent requests involve random read and write operations. For example, in the database of a large e-commerce platform, there are thousands of users at any given moment, querying products, right? Placing orders, and so on. These operations all involve different data records in the database. Random reading and writing. Because you don't know where the writing position is, right? As a user. Different users have different storage locations, and the content stored is also different. The content to be modified is also different. Okay. So every time a user makes a request, right, you have to help them according to their request. That means writing data, updating data, or reading data in the database. These are unpredictable. Our read and write requests cannot specify which position on the disk we are reading from or writing to. As we mentioned, a major issue with mechanical drives is that their random read and write performance is very poor. This is because once I choose a spot, you need to use the read.write head to find that position to read from or modify, right? So here is exactly this problem. With your database, the user's read and write operations are unpredictable. We have no way of knowing in advance what the user wants to read. For instance, a second ago, you might have wanted to read from database A. In the next second, it might be database B. Below it might have changed again, meaning the user could be switching between different databases, different tables, and different fields, adjusting back and forth. This is the issue with random writes, and mechanical drives handle random writes very poorly. It's very poor because of the limitations of the mechanical structure. Every time you look for data, the read-write head has to search on the disk surface. So finding data here, especially in the context of databases, is very challenging with mechanical drives. It's not that it can't be done, but the response speed will be relatively slow, which will affect the overall performance of our system. Inside our solid-state drives, there are no mechanical moving parts, so when handling requests, we actually use tables, right? We use our mapping table to directly locate the data, which can enhance the processing capability of our database. For example, taking an online transaction system as an example. When using solid-state drives to store data, the system can instantly respond to user actions like searching for products, adding items to the cart, and checking out, providing a smooth shopping experience. This is, of course, one of our examples. So for data that requires high concurrency and random read-write operations, we generally refer to it as hot data. According to the 80-20 rule, this type of data usually accounts for 20% of our total storage. For such A-level applications, it's very suitable to store them on solid-state drives. And it's best to avoid using mechanical drives. It's best to avoid using them. Next, our second type is B-level applications. For B-level applications, the main requirement is operations involving sequential read-write of large files. For example, when you are transferring files, images, videos, etc. Although the quantity might be large, they have the advantage of sequential read-write, meaning you can write them consecutively. Reading is also done sequentially, right? Writing is consecutive, meaning you find it once. For instance, if you use a mechanical drive, once the read-write head locates the data, you can read-write sequentially. Overall, you don't need to reposition the head to search again. This way, it's relatively better, especially for solid-state drives. Here, everything is arranged in a certain order. Regarding the data, actually, in this case, relatively speaking, for example, when you look at some things, like everyone is watching the current, hey, as for this video of mine, right? This video of mine is actually pre-recorded, right? It was recorded in advance and uploaded to our platform. In this situation, actually, the storage of our entire video is actually stored in, hey, this, on the backend server. At the same time, on the backend server, in this situation, when we are reading it, one aspect is that the content is continuous. That is, our data is continuous, so there is no need to frequently read or frequently use the read head to seek. In this way, actually, our mechanical disk, relatively speaking, performs a bit better and is somewhat easier to handle, of course. Solid-state drives are definitely better. Solid-state drives are certainly better. But if you consider the cost, you can switch to mechanical drives. In this case, you can switch to mechanical drives. In such a situation, both solid-state and mechanical drives can be used. In terms of solid-state drives, the performance will be better and the speed will be faster, but the cost is relatively high. For example, a large video website or a site with a lot of video files, these files mainly involve sequential read and write operations. If you store all of them using solid-state drives, the cost would be extremely high. But if money is not an issue for you, then it doesn't matter. So for such a large number of files, you can actually store them on mechanical drives to meet performance requirements and also control costs. The access frequency for these types of data is lower than that of A-level application data, especially since there won't be too many modifications. When you upload videos or images, it's a whole file, right? A complete file generally doesn't have many modification issues. You also basically won't update them, right? At most, you just add and delete, right? This type of file mainly involves adding and deleting, with updates being relatively rare. Updates are relatively rare, especially and also once you write it once. Generally, it's just written once, and afterwards, it's mostly just reading. Without much modification, mostly just read operations. The access frequency isn't as high as the A-level data we mentioned earlier. So here, you can actually use mechanical drives, although solid-state drives are better. And the last type, C-level applications, mainly focus on backup data. Or data that is rarely used, but it doesn't necessarily have to be backup data. Some data that isn't used much, right? Data that is rarely accessed can also be considered, and designing applications for these data might mean they won't be accessed for a long time. For example, like some of your historical records, historical logs, including things like backups of historical financial statements within a company, data backups, log backups, and so on, right? Backups of some project materials. For these types of data, our storage focus is on data security. And large-scale storage, right? The volume of our data is quite large, and we must ensure its safety without damage or loss. The read and write speed requirements are actually not high because we basically don't read or write, right? It's mainly for backup purposes. Generally, it's written once and then left there without being moved. So in this case, what can you do? You can use this. Here, you can extensively use our mechanical drives. Large capacity and low cost. You can even store it on tape. You can even store it on tape. Tape can also provide a very large capacity, and the cost is also relatively low. This is our C-level application. Mainly, you can basically use all mechanical drives. Using solid-state drives wouldn't be worth it. It's not worth it. And why is that? Because once you write it, it doesn't move. So you can't take advantage of the benefits of solid-state drives. Therefore, for this C-level application, there's actually no need to use solid-state drives. And then next, this. Here we have an important principle, which is the 80-20 rule mentioned earlier. The 80-20 rule means that typically 20% of the total storage is used for data that users need to frequently modify or read/write. This is what we call hot data, and it's referred to as an A-level application. For this type, we mainly use solid-state drives. The rest is optional. If you have the capability, you can use more solid-state drives. If you don't have much capability, then you can use more mechanical drives. This is our concept of tiered storage, where we place different content on different drives. This way, efficiency can be improved and costs can be correspondingly reduced. This is one of our approaches. The application of solid-state drives and storage is beneficial. If anyone wants to learn about Huawei certification technology or obtain the Washington question bank, please send me a private message. I can also engage in technical exchanges by leaving more comments below the video. Alright, let's stop here for today.